right, guys, this is going to be the recording for thermal energy that was either your Wednesday or Thursday lesson. And so I combined 2.2 and 2.3 together. And so clicking on the home page where everything lives, you're going to see the assignment and the attendance. And so today we are still focusing on the idea that molecules will speed up or slow down depending on how much energy they have. And obviously, if they speed up, they have more energy, and speeding up will also make them have a high temperature. Slowing down will obviously make them have less energy and have a low temperature. And we are going to focus on how energy is transferred. We did a little bit on Tuesday with our convection, conduction, and radiation. We're going to do some lab demonstrations on those on Friday as well. So we're kind of continuing to put all our ideas together. And so clicking on that assignment, oops, mine is scrolled all the way down. That does not help us. Here we go. All right. So we're focusing in on this investigation question, which is why do molecules change speed? And so there are two claims here. We have claim 1 that molecules will speed up when energy is created and slow down when energy is destroyed. And then claim 2 was molecules speed up when they get enough energy from other molecules and then slow down when they give the energy to other molecules. And so we kind of had a little discussion and kind of decided that claim 2 was the better claim, and that was because claim 1 is incorrect. You guys at this point should know that we cannot ever destroy energy. It does not go away. It is just transferred somewhere else. And so we kind of talked about that. And then at this box here, you're going to put which claim you agree the most with. And then throughout the lesson, you are going to be finding evidence to support that claim. And we're going to do that in two different ways. And the two different ways are going to be one through the simulation, and then second, there is a reading. So you can launch the simulation for our first part. And so what you're going to do is you're going to add two samples. So I'm going to add two medium samples. And then you're going to turn on the kinetic energy and the energy transfer toggle so you can see. And they want you to make one sample hot and one sample cold. And you can see that we can watch the energy being transferred up from the bottom throughout. You can also see that when I click the plus, my thermal energy increases, and so is my temperature because there's more movement. So the more movement and the faster these molecules are moving, the more energy I have and the higher my temperature is. And then over here, I'm going to make this one colder, and you can see the energy is leaving and being transferred out, and so my energy is going down and my temperature is going down. When I put them together, I want you to watch what happens. We can see this energy being transferred from hot to cold. And I played an obnoxious song, which I won't put in the recording, but the idea is that energy is always transferred from hot to cold. Hot has more energy, and so the more energy is going to be transferred to the area with less energy, which is cold, because the cold are moving slower, so they are not creating as much energy. And so now you can see that they're kind of evening out. This was way hotter in the beginning, and you could see the energy went down and the temperature went down because it was attracted to the colder side, and now they're a little bit more even. So the idea is that you needed to then tell me what evidence did that simulation provide for you based on our claim. And remember, our claim said that molecules will speed up when they gain energy and slow down when they are releasing that energy or passing it on. And then we read this article, and you can see I was highlighting it with one of my other classes. And so read this article, And then in this article, I'm going to erase this out of here, but this article had to do with air conditioners and how they work. And obviously that plays into what we're learning about. So there is one question in the middle of the article about how air conditioners work. And then down here, I wanted you to pull out some evidence from the reading that will support our claim again. And I'll give you a hint that air conditioners work in a way that has to do with molecules in the air and how fast or slow they are moving and our kinetic energy, because we know all of those are related and connected. And so once you do that, then you are done and going to turn this in. On Friday, we will have a weekly check-in, so make sure you come to class on Friday.